Welcome back everyone. In this segment of the lesson we're going to be looking at some more examples with regards to problem solving in measurement. Let's have a look at our concept map for this next part of the lesson. So guys, we're going to see how measurement assists us in problem solving with shapes, but also we're going to be talking about some strategies for specific measurement questions. Now, at this point, I'm just going to revise some of the important definitions with you, just so that I can make sure that everyone's on the same page. Cool. So, we know that the surface area can be defined as the area of a polyhedron that can be found by adding together the areas of each face of the polyhedron together. So, the surface area of a three-dimensional shape is found by adding the areas of each of the faces together. Great, the next definition is volume. So we've said that the volume of a three-dimensional shape refers to the capacity that the shape has. The volume of a three-dimensional shape is determined by working out the area of the base of the object. So that's always a good first step, is to find out the area of the base of the object, and then we multiply this by its perpendicular height. Again, please make sure that you star or highlight the fact that it's the area of the base by the perpendicular height. So the perpendicular height has a big role on this calculation. Great. Also, just a reminder that it is possible that the dimensions of a prism can be changed. The number that each dimension is multiplied by is known as the scale factor, and we often call this the scale factor of K. Great, everyone. Then lastly, before we get into the example, in general, if the dimensions of a regular polyhedron are changed by a factor of K, then the surface area changes by K squared and the volume changes by K cubed. So also please remember there are some exceptions to these rules, but in general, if we've had all of the dimensions of a polyhedron change, the surface area changes by K squared and the volume changes by K cubed. Great everyone, I hope that you're with me so far. We're now going to get into an example. Let's go back to the board. Cool, so a company produces shipping containers that are long and thin. Each container has a volume of 425 meters cubed. So we can see our shipping container that has a capacity or a volume of 425 meters cubed. Also, just another reminder, please remember that volume, our units are always cubed. So we're now going to look at what we need to investigate with regards to these shipping containers. So we first have to determine the area of the base, which is my shaded region present over here, if the height is 8 meters. So they're essentially saying, we need to figure out what the area of this base is if I tell you that the height is 8 meters. So, how do I work out the volume of a rectangular prism? Well, it's the area of the base, which is length times breadth, multiplied by its height. So we know that volumes of shapes are found by taking the area of the base and multiplying it by its perpendicular height. And because it is a rectangular prism, I know that this height will be a perpendicular height because I know my corner angles are 90 degrees. But for this particular case, it's interesting because I've actually told you what the volume is. I know that the volume is 425. But I want my area of my base, and I know the area of my base is the length times breadth. So I know that that's what I'm investigating. So we want to know what the length times the breadth is, but how I'm going to do this is by using the extra piece of information that I was given. And I was given that the height is 8 meters. So in order to isolate my length times breadth, I'm going to have to divide 425 by 8. So let's get my calculator friend out. So in order to isolate my length times breadth, I'm going to say 425 divided by 8, which is going to give me 53,13. So that means that the area of my base is 53,13 meters squared. Let's go on to the next question. So now we've been asked to determine the height of the container if the area of the base is given to be 21 meters squared. So this is kind of the opposite of what we just did. We know that the volume of a rectangular prism is the area of the base multiplied by the height, or the perpendicular height. We've been told what the volume is. I know that it is 425 meters cubed, so I can replace volume with 425 meters cubed. But in this case, I don't know what my height is, but I was told what the area of the shaded region is, and the shaded region is my base. So I'm going to replace my length times breadth with 21 meters squared, because I know that that's going to reveal what my height is. So in order to isolate my height, I'm going to have to say 425 divided by 21. Cool. So my height is going to be 20,24 meters. Great, everyone. Now the last question for this section is saying that the company produces the shipping containers have found that customers prefer a smaller and bulkier shipping container than the long and thin ones used presently in the diagram. They decide to increase the length and breadth of the container by a scale factor of 2.6. So they've changed the length and the breadth. The question is now asking us by what scale factor should the height be decreased of the container to maintain a volume of 425 meters cubed. So in this case, we know that my volume has been changed in the following way, because the length and the breadth, so it's going to be 2,6 times my length times 2,6 times my breadth times my height. So I've changed my length by a scale factor of 2,6 as well as my breadth by a factor of 2,6. But I want my volume to be maintained. So how I'm going to counteract that is by saying, what do I multiply my height with so that I'm going to get back to length times breadth times height is equal to my original volume of 425. And how I'm going to do that is by taking the multiplicative inverse. So we can see that if I multiply 2,6 by 2,6, it gives me 6,76. So if I multiply my height by a factor of 1 over 6,76, it will return to its original length times breadth times height. So for my new volume, it's going to have to be 2,6 times my length times 2,6 times my breadth, and then my height is going to have to be 1 over 6,76. Because then we will return to our original length times breadth times height. Great, guys. We'll be back after the break to do more examples. See you soon.